So, second to the last module for this course, uh, the transport layer, module 14. So this is the part 1. So in this module, we are to cover two transport layer components, TCP and UDP. We are also to look into port numbers, okay, importance of port numbers, very important information added by TCP and UDP to our data. We look into the communication process of TCP, then other characteristics of TCP under reliability and flow control, and then we look to also into, of course, UDP. One role of the transport layer is to provide segmentation. Okay. Again, in segmentation, what will happen is our data, okay, data being transmitted, it is being broken down into pieces. Okay. Example like that. Okay. Then, so this segmentation again happens here in the transport layer. Because of this segmentation, we'll be able to run multiple applications all at the same time. Like this one in this diagram, this says that, okay, you can use your phone and at the same time you can stream a video and at the same time you can browse the web or say use phone, okay, through the network. Okay, so that's how it is. Okay, so with that is we can say that the transport layer is responsible for the communication between the application running in different hosts. Managing it. Okay, managing the communication between applications running in different hosts. Okay, so another is its responsibility is to ensure reliable delivery, like with TCP, which is the agenda of this part. We'll discuss what is there in the reliable delivery as we move along in this discussion. So these are specific responsibilities of the transport layer. First, it tracks individual conversations. Just like with LBCOs or DHL, it has like the tracking number, okay? That like in the tracking number of LBC DHL, you'd know if where your delivery is, right? So same thing here in the transport layer. You would know if your data has been sent or not. Okay? What the receiver will do is to send an acknowledgement. It notifies the sender if the data has been received or not. And then I mentioned a while ago that again data is being segmented. It is being broken down into smaller pieces. Okay? There's that monitoring tool where we can see those segmented data. Okay, so this segmenting data happens during sending, and then on the receiver side, these segments are being reassembled. Okay, it converts back to its original form. There are a couple of added informations in the data. As we go along, we'll define this. We'll look into this header or added information. Um, there is a number that identifies applications and in effect conversations. Like there's a port number that identifies an email or an instant messaging or a web page. Okay, we'll look into this. We call it a port number, and we'll have a discussion on that. Okay, again, we owe it to segmentation. I mentioned this on the previous slide, and also multiplexing. Multiplexing is a concept where we combine multiple signals into a single channel. Let's say given that we have a single, say a single connection or a single channel. This channel, before legacy, it can only accept one form of data, okay, or one form of service. But nowadays, um, it can pass through simultaneous. It can pass through different forms of service through this single channel. You can have an email. Okay, let's say this is email. E, e there email, and then let's say at the same time you have your web page here, w, for example, w there. Okay, so you can transmit all of these multiple signals into a single channel, single connection. This is a connection, connection niya. Ayun. And we owe it to this multiplexing. Okay? So there are two main protocols or components. There are two main components inside the transport layer, and these are these two protocols, TCP, Transmission Control Protocol, and UDP, User Datagram Protocol. There are specific services or application layer protocol that uses TCP, and there are application layer protocols that uses UDP. You need to take note of that. IP both supports TCP and UDP. Okay? Uh, Again, transport layer is, it specifies how to transfer message between hosts, and this is responsible for managing reliable uh, delivery in a conversation. This reliability actually is a function of the TCP, but not UDP. Okay, take note of that. That's for TCP and not UDP. So now we discuss TCP. Again, TCP it stands for Transmission Control Protocol. Some of the functions of TCP is first, it tracks data segments transmitted. Okay, example, this guy here, he sent a file to the FTP server. Okay, so again, what happens on this data is it will be segmented. Let's say we'll divide this into two. So one and then two. Okay, first, to identify that this is the first segment, there's that sequence number. There's that sequence. Say, it's literally a number. Say 1, and then this is 2. Okay? So, for example, it can send these two segments all at the same time. So, send niya. Let's say FTP receives that. Okay? So, already FTP server receives these two segments, 1 and 2. What FTP server will do is to acknowledge. It will send a piece of, say, a piece of the segment, say this one, example, this one. We call this as acknowledgement, ACK, acknowledgement. Okay? This piece of data, this piece of the data, okay, or header rather, this piece of the header, it is to be sent back to the source or sender. When the source or sender receives this piece of acknowledgement, that is an indication of the sender, that indicates that it has been received by the FTP server. Okay? So, if not, example, let's say, uh, this 1 and 2 segments has not been received. So, obviously, that the sender will not receive any acknowledgement, diba? It won't receive any acknowledgement. So the sender will worry, why did I not receive the acknowledgement? I should be expecting it now. Okay? So what the sender will do is to retransmit. Okay, better. I think I need to resend it again. So you will send this data, these two segments. Okay? The process data, which are we have here yung two segments again. Retransmit. That's an error correction mechanism of TCP. Okay, again, keyword here is whenever data is being sent, it is being segmented, and then there's a tracking of the segments. There's one component on the tracking is the moment that a data or the pieces of segments are received, it is being acknowledged. If this is corrupted, it has not been received, so expected that the source will not receive any acknowledgement, and what the source will do is to retransmit. And then there's that sequence number added on the uh, segments to identify the order of the segments. Okay. And in effect, data is sent at an efficient rate acceptable by the receiver. Okay. This is what we call as flow control. We'll discuss this later. Okay. For user datagram protocol, it's considered connectionless. When we say connectionless, the sender, here the sender do not know if indeed it is connected to the receiver. Okay? It will take its chance. Okay? There. It's like, for example, like in the movies, you go to a place and you don't know, example, your girlfriend or your boyfriend. Okay, the usual story, you go to Dubai and then you are looking for your girlfriend or boyfriend and you don't know if they're still alive. Okay? And you don't know if you're still connected with them. Ba? Because sometimes we look for that closure. Okay? I think that's acceptable analogy. So there, that's UDP. You go to the place and um, hoping you are still connected with that person. It's still alive. There's still an established relationship. Same thing here. With UTP is it goes to this FTP, okay, but it doesn't know if they are if this sender is connected. They still have an established connection. It has an established connection with the destination. Like in this case, the FTP server. So it will try its best. Okay, that's why it's called as best effort. Okay, in delivering the uh, pieces of segments. There's no acknowledgement. Okay, in the data. There's also no sequence number in UDP, in the user datagram protocol. The good thing with user datagram protocol is that it's faster as compared to TCP, but because there's little overhead, okay, and there's no acknowledgement, there's no idle time. So we'll focus first on the sorry, before we focus on the TCP, I have here an overview. Well, I have here a summary of those characteristics that UDP and TCP has. And then another important thing to take note is that I mentioned this a while ago that there are a series of applications that uses TCP and there are those that uses UDP. We will explore on this later. So for the TCP, first, TCP is connection oriented. Okay? Connection oriented. What do we mean by connection oriented? So let's say I have two computers here, A and B. Okay, A and B. What we mean by connection oriented is before A, okay, before A sends data, before A sends data, so like this part here, this is already data transfer. Data. Okay, I better use my hand. I'll try. So this is data transfer. So before data transfer, what the uh, what TCP will do is to first establish a connection. It will send first hi. Okay, there hi, and then what after hi, it will send an acknowledgement, and then it will be acknowledged again. ACK. Okay, there. That's how it is. Okay, that's what we mean by establishing a connection. This part over here. That before is the data transfer, it first says hi, and then acknowledge, and then acknowledge. Okay? Just like us, diba? Just like us. When we say something, that's the data, we establish a connection first, right? Oh, example, you meet someone in the train station, diba? Before you ask her or his name, you say hi, and then the other one will say hello, and then you will say, uy, mapuwan ka pala. I saw your ID. O, di ba? Yung mga strategy nyo. There. Okay? And then that's the time you say, anong name mo? Oh, that's the data already. If you remember, before you get their name, his or her name, is you say hi first, and the other one said hello. Diba? So, that's the establishing a connection. Same thing here in TCP, ano? Uh, that's why we say TCP is connection oriented. It first establishes a connection. It ensures that the receiver is indeed connected to the sender. Next, reliable delivery. We mentioned a while ago that there's that acknowledgement, right? That once a data has been received, it is being acknowledged. So that's one component. One component of TCP, which that's why TCP is considered as a reliable delivery. Another, it has error correction, the resending. That if in case that the sender did not receive any acknowledgement, it is to be resent. Okay, and then here, same order. Oh, you think of this. What does TCP has that ensures that the order of the segments are observed? Yes, true. Okay, if your answer is that it has sequence number, yes. So there is a number added on the segments and that defines the order of the segment. Okay, ayun. This should be segments eh. Segments dapat. Segments can arrive in the wrong order. And then the flow control. In the flow control, if in TCP, if it sees that it has enough resource or say bandwidth, for example, that's one resource. If it has enough bandwidth, and in that bandwidth it can send, bandwidth is like a highway, okay? So if you can, if the highway is wider and you can send more cars, the better, right? So you don't limit, if you have, you don't limit sending cars, right? If you have a much wider road or highway. So same thing here, if the TCP sees that there's a much wider bandwidth, it will send more segments, in effect faster. So that's what we mean by supporting the flow control. Okay. So these are the specific added informations or header of TCP, added informations in the data. We have the port number, we'll discuss this later. This identifies applications. And then we have the sequence number that defines the order of the segments. And then the acknowledgement numbers, that the one that is being sent back to the sender. Okay, and that identifies that the segments are been has been received. So these three informations are the ones important. Aside from these informations, we have this. Okay, and then this one is the data already. Application layer data is the data already. Okay, header in TCP is around 20 bytes. These are the different applications of TCP. Most applications in the internet are in TCP. So our browsers uses TCP, also email, remote access, file transfers like FTP. Okay, TFTP is another file transfer, but it uses UDP. Again, TCP supports IP. And if you notice in our operating system, TCP and IP are paired, right? Uh, TCP is the one that fills the weaknesses of IP. And because TCP and IP, because of these two protocols, we have internet, right? They fill in each other's weaknesses. They're jowa. They are boyfriend, girlfriend, these two. Okay, and that's how a perfect jowa relationship is. You fill in each other's weaknesses. You bring out the best to each other. Okay, that's the good thing with TCP and IP. Okay, and they're very good partners. Uh, well, because we have internet because of these two protocols. Take note of that. This one talks about port numbers. Again, I mentioned that port numbers identify application. Okay? So, example, I have my client one here. Let's say given this is Mapua server. Okay, like example, this is the email and Blackboard. Example, this is the Blackboard BB. Okay, that's the BB server. And then also email. Okay, email server. Example, my mail. Okay, email. There. So let's say you go to your browser and then you type blackboardmapua.com or whatever the URLs. Okay. So the client will request for a page. So what the client side will do is to encapsulate the data with a port number. Okay. The destination port defines the service. So this 80 defines that that is an HTTP. Okay, that is an HTTP, that is a web page. You are requesting for a web page. And then, what client 1 will do, it will generate, the operating system of client 1 will generate a source port. Okay, it will generate a source port. The purpose of the source port is to identify the session. Again, take note, the rule, the role. The source port identifies, it is the unique, it provides a unique identity of the session. Okay, while the destination port, this identifies the application. Okay? For each application layer protocol, there is a specific port numbers. Okay? There are 1024 port numbers. You need to memorize not all the 1000, but there are a couple of port numbers you need to be aware of and memorize. Okay? That's how it is. So, if the server will reply, it will give the page of Blackboard to client 1. What happens is um, the destination port, the source port, okay, the source port in the request, uh, in the response, that becomes the destination port. So this 49152 in the server response, it will become a destination port. And then the destination, okay, right, diba? The source port in the request becomes the destination port in the response. And then the destination port in the request becomes the source port in the response. Okay? Take note of that, ha? Nag-i-interchange. That's the keyword, interchange. I mentioned a while ago that TCP is connection-oriented. Okay? That before data transfer, okay? Let's say this is the data transfer part here. Data transfer. Okay na yan, transfer. So first, it will send an SYN. This is like the high, right? It will first send that. And then what the receiver will do is to acknowledge. It will acknowledge the synchronization. Okay, that's what we mean by the SYN. Okay, once it is received, it will be acknowledged again. Okay, it will acknowledge the acknowledgement. That's how it is. Okay, take note of this specific term, SYN, ACK. Okay. There, we call this as three-way handshake. Again, this is called as a three-way handshake. Handshake. There, handshake. That's what we mean by this process. That's the term of this process. Okay. And then also, after data transfer, it is being terminated and similar to the three-way handshake. Handshake. It sends FIN and then acknowledge again. So again, we call it as the three-way handshake. Okay. These are the specific uh, flags, added information to take note under the three-way handshake. And then for the reliability and then guaranteed order delivery part, um, again, TCP is divided into segments. And to define the order of the segments, we have the sequence number. Just take note of that term, sequence number. Okay. And example, if a certain part of the segment has been received, what will it do? Resend. Thank you. Oh, good. Okay. That sounds weird, awkward. I'm not. Anyway, Dedma. So next, yun again, if the a part of the segments is lost, the mechanism is to retransmit this acknowledged part of the segments, okay, or data. And then in the flow control, this is the amount of data that the destination can receive and process reliably. Example, if it can send 2 or 3 or 4 segments, okay, uh, that's the flow control, okay. So, or if it can send only one, okay, because there's low resource available. So that's the flow control. If it can sees that there's a higher resource available, then it will send more. If the TCP sees that no, there's not enough bandwidth, there's not enough memory, so on and so forth that the system has, then it will send less. That's what we mean by the flow control. If you notice when we download files, okay, if you observe that, example, um, the window will say, so we have that notification that will say, oh, you have 1 hour remaining left. So because it sees that there's a um, fewer resource, there's many things that the operating system is doing, and what the TCP can do is to only send few segments. But let's say after 2 minutes, it will say, oh, 30 minutes. That is your time remaining to download the files. Okay? And then after 5 minutes, it will say 10 seconds. Right? So a while ago, you were waiting for 1 hour, but then again, you only waited like for 10 minutes. After 10 minutes, you already had the files. The files were already completed successfully. Were downloaded successfully after 10 minutes. But a while ago, it says 1 hour. Well, because of that, well, the reason for that is because TCP, if it sees, if it can send more, it will send more, and that's under flow control. Okay. And this ends TCP. I think I've said everything about TCP. Okay. Part 2 is about UDP and port numbers. I hope you continue watching this video. Thank you. Keep safe. Together we learn as well.